All right, in this video, we're going to be looking at lesson 1.1b. So this is the second half of that first section for lesson 1.1. And to start out with, I want you to take a minute to work on this warm-up. So this warm-up will be a good refresher for what you would have watched in the previous video or done in the previous lesson. So I want you to pause the video and attempt to try to find the domain and range and the intervals where the graph is positive or negative. Remember those intervals where it's positive or negative? We describe those intervals using the x-axis. So just a reminder about that. So why don't you guys go ahead and pause the video and hit play when you're ready to check to see how you did. All right, let's start with the domain and range. Remember the domain, we get that from the set of x values that are being graphed. And remember, we describe that as the easiest way to find that would be to squish that graph on the x-axis. And if you squish this graph on the x-axis, you'd have a line going in both directions. So the domain would be everything. So we can describe that as going from negative infinity to infinity. And then the range, that we get by squishing the graph on the y-axis. Now, if I squish the graph on the y-axis, you're not going to have any points above 10. All the points are going to be from 10 and below. Now remember, when we write this in interval notation, we always start with the smallest value first. So if you said that it goes from 10 to negative infinity, you have the right idea, but you want to have the order correct in order to get full credit. So we would say that it goes from negative infinity to positive 10, and positive 10 would be included as one of the coordinates, and so we'd have a bracket there. Now let's talk about where the graph is positive or negative. Now remember I said that the way that we determine if it's positive or negative, anything above the x-axis is positive and anything below the x-axis is negative. Now this is two separate intervals, okay, so where it's positive there. So we're going to describe those as two separate pieces. So the first piece starts where x is negative 12 and ends at 0. And the second piece starts at 0 and ends at positive 12. Again, we're describing that using the x values. So for what values of x would we get results? Would we get answers that are negative? I'm sorry, that are positive. This next part, we're looking to see where is the graph negative. So now we're looking to see for what values of x would the graph give you results that are negative. So that would be below the line. So that's those two segments. So the first segment there. Now, if you're having a hard time, think about it this way. Remember, we're describing it using the x-axis. So if I were to squish this graph on the x-axis for that segment there, we would have an arrow pointing to the left. So it would go from negative infinity to negative 12. Any point from negative infinity to negative 12 would have a coordinate that would be a y value that would also be negative. If we look at this second segment over here, and if I squish that on the x-axis, we'd have a line starting at 12 going towards positive infinity. So again, any value where x is bigger than 12, you're going to have an answer, a result, a coordinate that's negative. So for example, when x is 16, y is going to be like negative 40, something like that. So that's where it's positive and negative, and a review of our domain and range. One of the things that I wanted to talk about that hasn't been mentioned yet is this idea of function notation. Anytime we write something in function notation, we write it using a letter F or G or H, and that just names the function. What's inside the parentheses there, that is our input. So if we ever see something like this, it's saying when our input is 8, what's our output going to be? What's the answer going to be? So in this graph, when I look at where our input is 8, so I look here where x is 8, and that would give us a coordinate there where x is 8. And when x is 8, what's our y value? Our y value is at 10. Or if I said, again, I'm just naming this function h, if I said that x, our input was going to be negative 4, what's our output going to be? So when x is negative 4, that point would be right there, and the y value at that coordinate would be positive 4. So that's just a review of function notation and how to identify those values when we're given an input, because that did show up on your assignment yesterday. If you didn't get that, now hopefully that'll make more sense. All right. Let's talk about intervals of increase and intervals of decrease. Now, for intervals of increase, what we're looking for here is we're looking to see, again, where is this graph gonna be increasing from left to right. It's decreasing, we're going to be describing that using the x coordinates for where the function is going down from left to right, or decreasing from left to right. So in this graph, when we read it from left to right, we see that it's increasing until it gets to that point, and then after that point, it's decreasing. So where is it increasing at? So it's increasing along the x-axis until it hits 0. So from negative infinity to 0, it's increasing. And then as soon as it hits 0, it's going to decrease. And it's going to continue to decrease as long as x continues from 0 to infinity. So for example, if x were negative 4, y is negative 2. And then when x goes to negative 1, y is now at 1. So the y values have increased from negative 2 to 1. Now after 0, if I pick a point for x like positive 1, erase some of those lines. So when x is 1, y is 1. So when x is 5, y is at negative 3. So as x increased from 1 to 5, the y values decreased from 1 to negative 3. So as the x values get bigger between negative infinity to 0, the values for y are getting bigger. As the values for x get bigger from 0 to infinity, the values for y decrease. They go down. So it's very similar to where it's positive or negative. We still use the x-axis to make those descriptions. So sometimes our graphs will be constantly increasing and constantly decreasing. Okay, so I may not have two things happening at the same time like our previous example. So I want you guys to figure out the intervals. Okay, so the intervals where it's increasing and decreasing for both of these functions. So I want you to pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So for this first one, again, we're reading it from left to right. So it's decreasing until we get to that point, and then after that, it's increasing. So we would say start where it's decreasing. There we go. So it's decreasing from when x is negative infinity to when x is 2. Okay, we're not saying it's increase. We're not describing the y-axis, we're describing the x values. We're trying to figure out for what values for x is the graph decreasing. So it's decreasing from negative infinity to when x is 2. And then as soon as it hits 2, now it's increasing. So it's increasing from 2 to infinity. So hopefully you got that right. If not, make sure you make those corrections. All right, in this one, all that's happening is it's decreasing, and it's always decreasing. So no matter which points you pick, whichever pair of points you pick from left to right, it will always be decreasing. It's not increasing at all. All right, let's look at this. So the average rate of change. The average rate of change, we use that to describe how 2 points change over time, again, from left to right. Now, we can refer to average rate of change because that allows us to refer to any situation from left to right, even if it's not a straight line. But the process is the same as if it were a straight line, meaning, remember this idea of slope. Slope refers to the same thing as the average rate of change. They use the same formula. So what's here might look kind of confusing. It's referring to this graph over here on the right where we have f of b minus f of a. That's referring to the y values. If we take that change over the change in x values, b minus a, that would give us our slope. It's the same as y2 minus y1 divided by x2 minus x1. Another way to look at it is rise over run, which if we're looking at a graph, to be honest, it's a little bit more easier as long as you identify what the scale is, and I'll make sure you understand that here in a second. All right, so here it says, what are the average rates of change, or what do the average rate of change over these intervals indicate about the given functions? All right, so they give us intervals here. These are not coordinates. Okay, it's not the coordinate -2, 0 and the coordinate 0, 3. Those are three separate intervals. And then our last interval would be -2, 3. So what we're going to do is we're going to look to see what's our average rate of change in these intervals. So this first interval is referring to from when x is -2 to when x is 0. So from when x is -2 to x is 0, that's between those 2 points. And the rise over run, the slope, it doesn't increase at all. It doesn't go up or down. It stays the same. So it goes up 0 coordinates, or it goes up 0 units into the right 2 units. So I'm doing the rise over run. So it goes up 0 units into the right 2 units. Well, 0 divided by 2 is 0. The next one. So the next interval is from where x is 0 to when x is 3. So for that one, the slope, again, the rise, it goes up 0 units, it goes over 3 units. 0 divided by 3 is still 0. And the last one, noticing a pattern here, we're starting at where x is -2 to when x is 3. So the rise is still 0, and it goes over to the right 1, 2, 3, 4, 5, really doesn't matter, because 0 divided by 5, is still 0. So since the slopes are all the same, that tells us it's a linear equation. So if the slopes are the same, it's a linear equation. If the slopes are different, it is nonlinear. And obviously we can get that by looking at the shape of the graph, but the most important thing to take away from this is just how do we find the slope if they give us an interval. That's what I want you to take away from this. So let's do that again for this next graph. So we have the same intervals, -2, 0. Be consistent with my colors here, so 0, 3, and -2, 3. So start with that first one. So from -2, 0. So here's -2, here's 0. So I want to find the average rate of change between those 2 points. Now here's where using rise over run can be really tricky, but it's still easy as long as you catch this little wrench they're trying to throw into things. Because it'd be really tempting to say, oh, it's going down 2 to the right 2. So it's -2 over 2, so my slope here would be -1. The problem is we need to look at our scale. The scale on the y-axis is it's counting by 4s. So to go down, I'm going down not 2 units, I'm going down 4 units. And then I'm going to the right, the x-axis is still counting by 1s. So the x-axis, I'm going to the right 2 units. So -4 divided by 2 would be -2. So this has a slope or rate of change of -2. Let's look at the next one. So the next one, I'm going from when x is 0, so I know this is green, so here's still a green dot. So when x is 0 to when x is 3. So we want to find this average rate of change between those 2 points. So again, we're rising up. We're not going up 4 or 5 units. We're going up 9 units. The easy way to see that is because this is at 9. This is where y is 9. So I'm going to go up 9 units, and I'm going to go to the right 1, 2, 3 units. Well, 9 divided by 3 is just 3, so my slope there is +3. And lastly, for this one, to find the slope between -2 and 3, so again, that's when x is -2 to when x is 3, I'm going to go up, so now I'm going up from 4 up to 9. So I'm going from 4 to 9, so that's a rise of 5 units. And then I'm going to the right 1, 2, 3, 4, 5 units. So since these all have different slopes, they all have different rates of change, it's not a linear function, which clearly we can see from our graph that it's not a straight line. All right, let's do one more together, and then I'll have you do the one that says your turn on it. Okay, so with this one, again, we're still sticking with those same intervals. So the first interval is from -2 to 0. And then we're going to have 0 to 3. And our final interval is going to be from -2. Oops. -2 to 3. All right, so starting at -2, 0. So if we're going from -2, from when x is -2 to when x is 0. You can see that's a straight line. We're rising up 1 over 2. Now, clearly this is a linear function, so I'm not going to spend too much time on this one. But this, it does get a little tricky. We never want to leave a decimal in our numerator. So yes, we do go up. We're counting by our y-axis and our x-axis are all counting by 1. So we would go up 1, 2.5 units. And then we would go over, oops, I'm sorry, we're not going from -2, we're going from 0. So from 0 to 3. So we're going up 1.5 units, there we go, and going over 3 units. But that's not proper. We either want to write it as a single decimal or a fraction. So if you did something like this, I'd have you on your calculator take 1.5 divided by 3. Otherwise, hopefully you recognize it's going to be the same slope. It's going to be 1/2. And then lastly, this one, we're going from -2 to 3. So from when x is -2 to when x is 3, that's also going to give you a slope of 1/2. So all three of these have the same slope of 1/2, so you can see it's a linear function. All right, now I know this last one is not a linear function, but the goal here is I want to make sure you understand how to find the slopes in these intervals. So I want you to end the video by trying this on your own. So I want you to find all three slopes within these intervals. So pause the video after you get done writing down these intervals. I want you to find those slopes now and pause the video and hit play when you're ready to check to see if you've done them correctly. All right, let's see how you did. So from when x is -2 to when x is 0, that you can see our slope. Again, our x-axis is counting by 1s, our y-axis is counting by 1s. So we're going down 2 units into the right 2 units, so our slope there is -1. Then the next one, going from when x is 0 to when x is 3, I can see that I'm going up 3 units and to the right 3 units. So our slope there is +1. And lastly, going from -2 to +3, we're only going up 1 unit, but then we're going over 1, 2, 3, 4, 5 units. And that can't be reduced, so our slope there would be 1/2. The fact that, all three of those slopes are different means that we are not working with a linear function. The most important piece here is to make sure you know how to find the rate of change given an interval. So that's it for this first section here of 1-1. So good luck as you work on your assignment.